Am I audible now? What happened? Hello, am I audible to you, all of you? Okay, so let's start the topic. Today, actually, I will discuss the IOQM problems. I will start with this particular one. Please confirm me that if my voice is clear and you all of you can see my screen, then I will start this. Okay, so my voice is clear and all of you can see the screen, right? Great. So this is the problem number 16. This is the problem number 16 in IOQM. Okay, this is a very easy geometry problem. It says that x and y are the scaling triangle, okay, which actually satisfy that x plus 2 delta x is equal to y plus 2 delta y. Okay, it says that x plus 2 delta x, 2 delta by x is equal to y plus 2 delta by y. So here delta actually represents the area of the triangle, and it's given that x equal to 60 and y is equal to 63. Okay, so what is the length of the largest side of the triangle? All right, so obvious idea is actually x and y is given. So through this relation, actually I can easily calculate the delta, right? I can easily calculate the delta. So let's calculate the value of delta. So if I just plug in, so 60 plus 2 delta by 60 is equal to 63 plus 2 delta by 63. So basically I just plug in the value of x is equal to 60 and y is equal to 63. I'm not going to use Heron's formula because Heron's will be very complicated in this case. Heron's will be very complicated in this case. So if I just simplify it, so it is 2 delta by 60 minus 2 delta by 63, that is equal to actually 3, right? That is actually equal to 3. Well, so this is 2 delta, this is 2 delta, and it can be written as 1 by 60 minus 1 by 63, it is equal to 3. Now 2 delta is equal to, okay, rather I should simplify over here, that it actually 3 by 60 into 63, that is 3. Well, So 3 and 3 basically cancel out, and 2 delta is equal to 60 into 63. Well, so delta is basically nothing but half into 60 into 63. Realize it's a very interesting thing that we get. Delta is equal to 1 by 60, 1 by 2, 60 into 63. Basically 60 and 63 is what? It are nothing, just the length of the triangle. Right, it's a nothing, just the length of the triangle. So we have a triangle, and suppose this is x and this is y, and we find out the area of the triangle is actually half into x into y. Okay, so I should x into y. All right, so basically it is a right angle triangle, right? Because it's, I'm getting that it is half into base into height, so obviously it's a right angle triangle. Okay, so this is a right angle triangle. So if it is a right angle triangle, then we can easily find out this is 60, this is 63. So obviously this will be root over of 60 square plus 63 square. Okay, so it's the thing. All right, it's a very simple problem at all. It's a very simple problem at all. If you realize that delta is just equal to half into the product of the side given. So any doubt? Yeah, if you simplify it, you get the 87 as answer. If you just simplify it, you get 87 as your answer. That's it. Clear to all of you? Okay. Then let's focus on the next problem. Okay. Well, so this is the second problem. I think this is problem number 15 in original IOQM paper. It's a problem number 15. So what it says? It says that three couples seek for a photograph. Okay, in two rows. So there are two rows, and in each row they sit for a photograph with two rows, and in each row three people, and it says that no couple is sitting in a same row or next to each other or in a same column. Okay, one behind the other. How many such arrangement are there? A very nice problem. So the key idea of means whenever we encounter this kind of problem, the key idea is actually looking for the diagram of the arrangement. Means we generally draw the rows and draw the column, means so that we can actually realize what is actually happening. All right, so assume that we have the couples B1 G1, means I'm taking this couple B2 G2 and B3 G3. Suppose these are the couple, right? Okay, obviously you can share your solution. So Urdeep, so there are some cases, means I can just simply make it a case 1. Obviously there is no problem, if okay, so suppose that actually our b1, b2 and b3 in the first row. Okay, suppose b1, b2, b3 in the first row. So obviously I can't put g1, g2 and g3 over here, because it actually make a contrary to this fact that this second line, that they can't be in the same column one behind the other, right? They can't be in the second column one behind the other. So if there is b1, the only possibility that here can be actually g1, g2 or g3, right? Only possibility is actually g1 or g3. Okay, so Deep is saying something. Take the couple A1, A2, B1, B2 and C1, C2. Now consider only A1, B1 and C1. Okay. Okay, in the in between time, I'm say my idea. Okay. So actually you can realize it is something called dearrangement, that B1 can't go to with G1 and B2 can't go to with G2 and B3 can't go to with G3. So it is something called rearrangement. If you have learned some basic combinatorics, I think you know what rearrangement mean. It's something means proper object does not go to proper place. One of the famous problem is the envelope problem, that proper letter does not going to proper envelope. So it's something like this, that B1 is not going to G1, B2 is not going to G2 and B3 is actually not going to G3. All right. Okay. So number of dearrangement, how many such dearrangement are there? Actually, how many way I can actually arrange this B1, B2 and B3? I can arrange B1, B2, B3 in 3 factorial ways, right? In 3 factorial ways. And for each of these 3 factorial ways, if you have the basic idea of dearrangement, you know that these girls or this female can be actually dearrangement in 2 factorial ways, right? So this is this 3 factorial actually the arrangement of this male or the boys, and 2 factorial is the arrangement of female, the girls, right? And finally, not necessarily that B1 sit in the first row and the girls have to be go for the second. It may happen that your boys and girls just alternate the rows, right? So it may happen that this G1 actually all the girls actually sit for the first row and the boys actually go for the second. So there are actually two ways. So there are actually two ways. So this is the actually the number of alternation of row, or it's actually come for arrangement of row. Arrangement of row. All right. So it is simply your 6, this is 6, and this is 2, and this is 2, so this is actually 24. Okay, well, so this is actually 24, right? Clear to all of you? It's the one case that when the boys are sitting together and the girls are sitting together, right? Now we can consider the second case, that when the boys actually some there is both the boys and girls in a same row. So here also try to draw a figure, it will be easier for you to understand. What is actually happening. Well, so suppose that there are one boy B1, there is another boy B2. So realize, suppose these B1 and B2 are here. So automatically realize that G1 and G2 can't be in the third place. G1 or G2 can't be in the third place. Only G3 can be in the third place. Well, and now as you put G3 here, realize the second row automatically get fixed, that it will be some G1, G2 and B3. It will be some arrangement of G1, G2 and B3, right? It will be the G1, G2 and B3. Actually, if you think, nothing actually get changed. Nothing actually get changed with the last one. Okay, actually we have just replaced B3 with G3. Okay, nothing else. Means if you just think that you just sweep the position of G3 and B3, okay, actually you get the same arrangement like the previous one. Okay, means what I'm actually saying, that suppose in a case 1 you get some arrangement like this, that suppose it's just an example, suppose G2, G3 and G1, and correspondingly you get a suppose B1, B2 and B3. All right, suppose you get this arrangement in the first case. In this case, realize in the second case, suppose this is a case 2, nothing actually get changed. Just you have to sweep the position of B3 and G3. You automatically get a new arrangement. So just sweep the position of B3 and G3 like these two. Okay, so G2, B3, G1 and B1, B2, G3. Okay, so you automatically get the one arrangement for the second case. Well, so for the every arrangement of the first case, there is a second arrangement of the second, there is another same arrangement of the second case. It is clear. Means if you look for the number of element for the first case, correspondingly just shifting the position of 2%, you get an arrangement of the arrangement for the second case. So if there are actually 24 element, there are if actually 24 element in the first case, there should be 24 element in the second case also. It is something called bijection. Actually these two sets are actually bijective. Clear to everyone? So it's actually a bijective, right? So the second one will be also 24. Okay, so case 2, the answer will be also 24. Well, similarly you can do the case with, now here you have choose B1, B2, G3. In the next case actually you can choose B2, B3, G1 and B1, B3, G2. So totally this kind of arrangement are there. So totally I have 4 arrangement. Okay, there are totally 4 ways, 1, 2, 3 and this one B1, B2 and B3, and for each of the arrangement the second row is actually getting fixed, and you are getting 24 for each of them. So actually this will be 24 into 4, so that is actually 96 ways. Okay, so that is will be 96. Yeah, Sauradip gives a, but here B1 and G1 are in the alternate places. Means I don't understand what you say, Amit. Okay, sure. I'm explaining. Second case is just with one girl. Okay, I'm explaining. It. Actually, what I am saying that you get something like this, right? That B1, B2, B3 in the second case, right? B1, B2, B3. In the first case, you have B1, B2, B3. You just, if you focus over here, okay, B1, B2, B3, and here is some arrangement. Suppose here B1, B2, B3, and correspondingly, suppose your one arrangement is actually G2, G3, and G1, right? So when you are actually making second case, case 2, realize that it is nothing, just the G3 and B3 actually alternate or change the place between them, nothing else. Okay, first tell me if it's clear to you or not. Who is right? I'm not right, Aryan? No, the solution may not match, but the answer is, if the answer is get matched, then it's perfect, right? What's the answer Sauradip says? 96. And what the answer I say? 96. So obviously it's true, right? Okay. So that's the thing actually I am saying. Maybe his solution is correct. I don't have the time to look into the solution. So, but I hope the solution is actually correct. So suppose that for the case 1 you have some G1, okay, G1 can't be there. Suppose that you have G2, G3 and G1 like this. So when you have to make the second case, what you have to do? You have to just, suppose you are looking for the, suppose you fixed your position for the first row, you fixed your position, suppose B1, B2 and G3. All right. So realize that if you take this thing in a first row, so second row automatically will be some arrangement of G1, G2 and B3, right? So realize, and it's the second set. Okay, so and the first one is actually B1, B2, G3 and G2, G3, G1. So realize that it is nothing. Here just G3 is actually replaced, or G3 and your G3 and B3 just make the change of their position. So if I look into all the arrangement for this case, so I will just change the position of G3 and B3 and I get a new arrangement. That's it. I get a new arrangement for the second case. So for each and every arrangement of the first case, actually I get one particular arrangement for the second case. So if it's an arrangement, just shifting of the position of G3 and B3, I get a position of this arrangement. If this is another arrangement, just shifting of the position of G3 and B3, I get another arrangement. So obviously you can realize that two arrangements are actually equal. So if the first ends give me the 24, the second also give me the 24, because it's the second arrangement just coming, just shifting the position of G3 and B3. So similarly, the other two cases happen, that B2, B3, G1 and B1, B3, G2. Okay, because here you have fixed B1, B2, G3. Similarly, you can actually take B2, B3 and G1, and B1, B3, G2, something like this. So totally you have four cases. One case is B1, B2 and B3. Second case is B1, B2, G3, B2, B3, G1 and B1, G3, G2. So it is actually four cases, and each of this case give me the answer 24. So totally 24 into 4, that is equal to 96. Okay, some people have the confusion, so that's the thing. Yeah, maybe the more easier solution is there, most easy, but I get the solution, so I just share my idea. Everyone, excuse me, everyone may have their unique idea. Okay, all right, let's move on to the next problem. So the next one is with simple problem actually. I hope that all of you, those people who have attended this test, have done this problem, because I hope that this is one of the easiest problem in this paper. And this is the problem. This is the problem. Okay, no problem, Sordeep. And you thought the entire idea in exam, so obviously you have much credit than me. I am thinking this thing in the fresh air, in a free mind in my room, and you are doing it exam hall, so obviously you have much credit. Okay, so it's a much easy problem, that the product 55, 55, 60 and 65 is written as a product of 5 distinct positive integer. Okay, and what is the least possible value of largest of this integer? So but just by simply observing you can actually solve this problem. You don't have to work too much. It is actually 55 into 60 into 65. So obvious way is, first of all, make a prime factorization as much possible. So if I make the factorization, so this 5 into 11, it can be, there are a lot of factor can be done, but one factor can be 2 into 40, sorry, 2 into 30, and another factor can be, here the factor can be, actually I am trying to break it in the largest factor, and it is actually 5 into 13. But the problem is, here actually I get, here I get 6 factor. So obviously this is not allowed. 5 into 11 into 2 into 30 and 5 into 13. Obviously this is not allowed at all. Well, so I will try to merge some factor, and okay, so distinct, okay, one thing we need to observe, that these 5 are actually distinct integer. We have to look into this distinct, otherwise lot of case may happen. For example, 5 and 5 is not distinct in this case. Okay, so what is the least possible value? Okay, so obviously it can be least, because if I take 10, if I take 2 and 5 at the same time, so it is actually 10 into 11 into 30 into 5 into 13. Obviously it's a factor, but this is not work, because it can be, okay, so another way of factorizing it is actually 5 into 11 into 13 into 15, okay, and into 20. And I think it's the most lowest value. 20 is the least possible largest value, because if I actually take any factor from 20, it will combine some factor. Means if I take any factor and if I multiply it, so it actually getting the much bigger value. So obviously 20 is just most easy, sorry, most is the least possible value of among these largest integer, because there can't be much less value than this, right? So I think 20 is the answer. Yeah, a lot of people do this thing. It's the most easiest problem in this paper. It's a very easy problem. Okay, let's try with a geometry problem. Another geometry problem, because I like geometries. So that's why let's do some with geometry. Fifteen can't be this thing. Same year construction for 15. Anyone say me the construction for 15, that the 15 is the largest and you can't uh, break it more in 5 factor? It will definitely not work. Well, sixth one, no, I think. Which one? That's we are doing. That one, I think. Problem number 14. That was problem number 14. Well, so now we are looking for problem number 19. It's the problem number 19 in IOQM paper. Okay, so let's try to draw this thing. I don't know how to draw using it. Let ABCD is a parallelogram. ABCD is a parallelogram, and E and F are the midpoint of AB and BC. So it's our E and BC means this thing. E and F are the midpoint. Well, so line EC and FD. So if I join this line EC, this is EC and FD. If I join FD, they intersect at the point P. Very good. And it actually form 4 triangle. one triangle is APE. Okay, one triangle is APB, something like this. Another triangle is BPC. Okay, BPC. Another triangle is CPD. Another triangle is DPA. So we are interested in this fourth triangle. This one, this one, this one, and finally this one. We are interested in fourth triangle, this fourth triangle. And it says the area of a parallelogram is actually 100 square unit. 100 square unit. What is the maximum area in square unit of a triangle among these four triangles? Okay, great. So anyone have any idea what to do? Yeah, CMI exam will going to happen on 27 June, but it is not the CMI entrance, it's the paper from IOQM. So please don't distract others. Anyone have any idea what to do? Well, so let's clear this figure. Okay, so this is the midpoint. This is the midpoint, right? So realize as this is the midpoint and as your P is here, so I am focusing on the triangle. I am actually focusing over the triangle APE. I am focusing over the triangle APE and triangle PEB. Okay, so realize that their height is actually same and these two lengths are actually equal. So obviously their area are same. So obviously their area are actually same, right? So I can mark like this that this area is same as this area. Why? Because this is the, it's very simple fact that if you have a triangle and if the height is actually same, if their height is same, so it actually depend on the, so suppose that ABC is the triangle. So as their height is same, if you draw a perpendicular from here, if you draw a perpendicular of triangle A by area of triangle ACD is nothing but half, suppose this is a common height, so its height H into BC and it's a half into height H into CD. So realize that this actually depend on the ratio of their bases. So it's BC by BD. Alright. Now we know that A is equal to EB because it's given that E is the midpoint of AB. Okay. So they are actually same. So they are basically same. Okay. So these two areas are basically same. Sort of line. So I can take that this is our area A and this is our area A. right? So these are actually same. Similarly, same logic, you can say that these two area are same. These two area are same, so it's actually B. It's actually B. All right. And you can take it at our C, and you can take it as our D. You can take like this. Okay. So we need to. So it's our goal. Our goal is to maximize. A, B. One of the, actually we need to find out this thing. Our goal is to find the maximum of twice of A, twice of B, C and D. All right, because we need to A, P, B, and we know that these are twice of A and this is twice of B. All right, but another condition is given. This given condition is this, that the parallelogram have a area 100 square unit. It is also given that twice of A plus twice of B plus C plus D is actually equal to 100 square unit. So this is a constraint. In this constraint, I need to maximize this thing, and I have to find out the maximum value of one of this thing, right? Well, well. So next, I am okay. So what to do here? I have to maximize this thing. A, B, C, D. Mhm. Okay, so if I apply our simple AMGM inequality over here, so what I get? Any idea using AMGM inequality? If I apply our AMGM inequality, because all of them are positive, so twice of A plus twice of B plus C plus D by 4 is actually greater than equal to fourth root of actually I don't know that it will work or not, but still actually I'm checking this. Actually I have another solution, but actually suddenly the idea of AMGM inequality comes in my mind, so just I'm checking that if it is actually possible or not. Twice of A twice of B into C into D, so it is 100, so it is actually 25 by 25, so that is actually greater than 4 A B C D, that to the power 1 by 4. No, actually there are a lot of constants are coming. You can't do like this. Well, not a problem. I just check that if it is possible using AMGM inequality or not. Well, so what I'm doing, I am actually extending this PE such that it actually cuts somewhere this line AD somewhere. So suppose this intersection point is our M. Okay, suppose this intersection point is actually our M. Okay, now basically realize that if you look into these two triangle, means if you particularly focus on this one and this one. Why I am focusing on this one? Because it's very simple that here these two are equal, and this is actually, this angle is same as this angle, right? These two angles are actually same. So obviously there is a chance, of being congruent. So if there is a chance, I don't know it is congruent or not, but there is a chance that triangle AEM is actually congruent with triangle PEB. Okay, it may be congruent with this triangle, I don't know, it may be, and that more possibilities to congruency with EBC. So maybe it's actually EBC. Let's see. And yes, if they are congruent. Why? Because these two angles are also same. All these angles are same. So this angle is same with this one. This angle, sorry, this angle is actually same with this one because they are actually parallel. These two blue angle are same. Similar logic, these two red angle are same. This red angle is same with this red one, and these two sides are equal. These two angles are same, so obviously they are equal, right? So they are actually congruent. So this is actually congruent, right? These two are actually congruent. Okay, so if I actually focus, if I actually focus over, right? So same. Hmm. So what can I say that? Okay, so the height is, the area is actually given, right? Hmm. The area is actually given. No, I'm not speaking. Actually, I'm thinking a bit. Uh, if I am apply AMGM inequality, the one of the answer can be 50, right? The equality, if the equality condition occur, then answer may be 50. Using AMGM inequality, I can prove the answer is 50, but well, so if I apply AMGM inequality here, means the previous idea that's actually I was using there, that our twice of A plus twice of B plus C plus D by 4, okay, this is actually greater than or equal to our fourth root of, okay, so 4 of A B C D, something like this, and it is actually 1 by 4. If I apply this thing, so it is 25 by 4, and it is actually greater than equal to, sorry, 25, that is actually 25 to the power 4, that is actually greater than is equal to 4 A B C D, right? 4 A B C D. No, it's not coming like this. Mhm. Mhm. It's not coming like this. So, okay, the original method. The original method is bit trickier, but it actually giving. Now, okay, so I find out that okay, my original method is actually this, that these two triangle are actually congruent, right? These two green triangle. If these two green triangle are congruent, so obviously this area is A and this area is B. So obviously, okay, so this area, this green triangle area actually will be, means area of triangle AEM. The triangle area of triangle AEM actually will be A plus twice of B, right? A plus twice of B means area of only this portion, A of twice of B, because this is A, this is B, so A of twice of B, right? Now, now on the other hand, realize that well, so it is my FD and FD. Other hand, realize that if I focus on this triangle and this triangle, if I focus on these two red triangle are similar. Can you find it out? It's very simple to find out is similar, because this angle is same as this one. Okay, this angle is blue angle is same as this blue angle, and okay, not that red angle. I actually make a mistake. This triangle, this triangle over here, this one, right? This triangle and this triangle, these two red triangle are actually similar to each other. Okay, these two red triangle are actually similar. So I can say that triangle. I can say that triangle DCM, triangle DCM is similar with triangle D is F. Oh, sorry, not DCM. D. What is C? Why I write C over here? Okay, this is the area C. Actually, this is P. This is DPM is same as FPM. F FPC. Sorry, FPC. DPM is similar with FPC. Okay, FPC. So now, if I basically apply the similarity over here, so what I have? I have, okay, so area of the triangle CDM, area of triangle CDM or DPM, area of triangle DPM means that triangle is what actually DPM. Area of the triangle DPM is actually equal to A plus D plus, here I find it out that AEM actually twice of A plus 2B. So it is actually A plus D plus A plus 2B, right? It is A plus 2B. All right. So this is actually twice of A plus twice of B plus D. This is actually twice of A plus twice of B plus D. Okay. And what is the area of triangle FCP? The area of triangle FCP, sorry, FCP or PFC, whatever. PFCP means this triangle. What is the area of this triangle? Area of this small triangle. Suppose I am dropping a perpendicular from here. If I drop a perpendicular from here, something like this. If I drop a perpendicular from here, so it is nothing but 1 by 4. Suppose this perpendicular have the length h, so this is actually 1 by 4 into h into fc. Okay, this is 1 by 4 into h into fc. What uh which area? Area is b. No, I am just saying about this one. Okay, the area is b. All right. Hey, yeah, this area is actually b. Yeah, that's good. This area is b. This total area, I know it's I find it out, it's from here, but actually I'm trying to calculate this area in different way. Okay, 1/4 into H into Fc. Well, next, so if I extend this length here, so obviously realize as this is a perpendicular, so obviously this will be the perpendicular, right? This will be also the perpendicular as this is on this perpendicular. So this is suppose height h, I assume this height h, so suppose this is height h1, suppose that this is actually height h1. Okay, this is actually height h1. So h1, this is height h1. So area of the triangle A means that I'm wish to find out D. Okay, so D is actually equal to area of triangle APD. APD, yeah, APD or DMC. You can also say DMC. Yeah, you can, in spite of like this, you can say DMC. Oh, area of this big triangle, because I find out they are similar, so I can use this thing. Hmm. Well, should I need this thing? Okay, better idea. In spite of doing this thing, a better idea. Realize also, yeah, I just suddenly this idea stuck in my mind. Okay, I'm drawing a fresh figure, so it will be better for me to explain. So it can be drawn. It can be shown much easily. Yeah, yeah. Yes, this idea should come in my mind first. Actually, I'm thinking that I need to apply this theorem somewhere, but I can't realize where how to apply this thing. Okay, so I extend this thing, just the same thing as I did over there, and then I have to join this with this one, and then I take a point P over here. Okay, no, then I have to, this is suppose E, and this is my E, this is the point F, so I join these two, and this is my point P, and I am looking for this triangles, right? Yeah, and I say that this is our A, this is our A, this is our B, this is our B, this is C suppose, and this is suppose our D, and I name it as our A B C D. All right, now we have previously proved that our, suppose this point is M, so I already proved that this triangle is similar with this one, right? I already proved it. So as I proved it, so obviously this length is same as this length. Again, this is a parallelogram, so this length is same as this length. So these two lengths are same, right? These two lengths are same. Now what I proved, I actually proved that these two triangle, this blue triangle and this blue triangle are actually similar. These two triangles are similar. So as they are similar, so obviously as they are similar, so I am looking for the, so let's take the perpendicular like this. Let's take the perpendicular like this. Well, suppose this perpendicular has the length h1 and this, okay, so suppose that this perpendicular has the length h1. Suppose this perpendicular, I'm marking here, suppose this perpendicular has the length h1 and this perpendicular has the length h2. Okay, this perpendicular has the length h1 and this perpendicular has the length h2. So as they are similar, so now I am actually applying the proportionality of the side, that is dm over fc is equal to dm over fc is equal to anything. You can realize that it is actually same as if you focus only on this portion, anything you can, if you take this to equality, so it is actually same as pf by dc, whatever, pf by, oh no, not pf, the pf will be in the denominator, dc by pf, something like this. Something like this. Well, now I am looking into the ratio of these two triangle. I am looking into the ratio of these two triangle. So the ratio, suppose that your FC have the, okay, so area of the triangle PFC is equal to half into this H2 into your length FC, right? And area of the triangle, this thing, the bigger one, that is DMP is equal to half into H1 into DM. Okay, H1 into DM. Okay, very good. Now DM, realize that DM actually equal to so this can be written as half into H1 into DM. DM means 4 of 4th, because this is the half of this thing and DM actually half of AB. DM is twice of AB, means AD is twice of half of DM, and again FC is half of AD, so it is actually 4th of FC. Okay, so it basically cancel out, so I find out it is actually twice of FC. It's actually twice of FC. Now you apply one important thing over here. You apply a very important thing over here, that if we have two similar triangle, okay, if we have the similar triangle, so obviously you can try to prove it that their area is actually dependent on the height of the ratio, right? Ratio of their height, right? So obviously here FPC is actually equal to your FPC by, if you look for, sorry, PFC by area of DPM, it's a DMP. So obviously that will be dependent on their height. So this is basically H1 by H2. Okay, this will be basically H1 by H2. Which one is H1? PFC. Sorry, H2 by H1. H2 by H1. So as this is H2 by H1, as this is H2 by H1, so H2 by H1 is actually equal to 1 by 2 of Fc, because 1 minute. The entire thing is actually, yeah, 1 by 2 of Fc by 2 of Fc, right? Or H1 by H2, I think H1 by H2, not H1. So H1 by H2. This is actually equal to 1 by 4 H1 by H2. So your H2 is equal to 4 of H1. All right. Okay. So H2 is equal to 4 of H1. Clear? Yeah, it's a bit confusing. Try to realize this. I'm giving some minute. Try to clarify everything your own. You can realize we are just finished. We're just finished. There is nothing left. These are some last steps only left of. Others, everything is done. Okay, right? So now, so it's our H1 and it's our H2. So what is the total height? So suppose H is the total height. So H1 plus H2, that is actually your 4 H1 plus H1. So that is actually equal to your 5 of H1. So it is actually equal to 1 by 5 H into H1. Okay, 1 by 5 into H1. Okay, fine. Now your total area, you know the total area, you know actually the total area. You know the total area is actually 1000, it is given. So this is nothing but your base into a height, so that is actually your BC, that is nothing but BC into H. Okay, that is BC into this total height H. So that is actually BC into 1 by 5th of H. So H is equal to basically H1, 5 H1. So it's actually 5 H1. So BC H1 is actually 20. BC into H1. Now BC into H1, that means BC into H1, that means actually your twice of B. That means actually your twice BC into H1 means BC into this H1. That is actually twice of B. Realize? So this is actually your twice of B. Twice of B is actually 20. So actually B is your 10. sorry, now I have to divide it by half. So I divide both side by half. So this is 2, this is 2. So the b is equal to 5. So your b is actually equal to 5. Now we have find out a relationship over here that our b is actually equal to 5. I know our b actually will become 5. Okay. So I have this thing that a plus b plus c is actually equal to 100. Again, I actually know that our okay. So what is the area of a plus b? Anyone can say the area of a plus b? Area of a and area of b? No, no, we are done. We are already done. We don't have to do anything. We already find out that our b is equal to 10. As we know b is actually equal to 10, we can find out the rest of the thing. We already know that our twice of a plus twice of b plus c plus d is actually equal to 100. Right, now we know that our b is actually 10. So obviously I know that 2a plus c plus d, that is actually our 80. That is actually equal to 80. Okay, that is actually equal to 80. Can anyone say me what is the area of a plus b and what is the area of c plus b plus c? Anyone knows? B is equal to 5. Oh, sorry. I completely got confused. B is equal to 5. B is equal to 5. So twice of b is actually 10. So this is actually 90, right? Yeah, this is actually equal to 90. Anyone? Okay, someone actually saying the answer will be 50. I don't know. But I think the answer should be 40, right? Most of the people are saying the answer is 40. Then how to complete it? We know the length of b, sorry, the area of b. Okay, so what I have to do? I have to find out the maximum value, right? The maximum value of these things. Hmm. Okay. Okay. Hmm. So next, I know the B this thing. I know DPM. I know the DPM, right? So DPM by our this thing, that is PFC, is actually dependent on the height H2 by H1, height H2 by H1. Now this H2 by H1, I find it out, this is actually nothing but 4. Okay, and I find out this thing is actually 5 because this is nothing but B, and this DPM is nothing but this, twice of A plus twice of B plus D. So twice of A plus twice of B plus D is 20, is actually 20. Okay, is actually 20. We just multiply it. Well, but if I make it 20, nothing comes. Twice of A plus twice of B plus D is 2 by, no. Something is going wrong. Something going wrong. Wait a minute. I'm just thinking. Uh, Right. Right. See. Hmm. Well. Okay. Now realize a easy thing. Means it's. I know that this thing is actually, this problem is very boring. Getting very boring, and I am also a bit confused with this solution. Uh, Now, if I join this thing, realize that actually this area, this green area, is same as this area, because they are on the same base and uh, same height, right? So that's the reason. So hmm, so this area also will be C. Now, what our A plus C? Our A plus C, sorry, our wait. So B plus C. So B plus C. Okay, so this area is C. So B plus C means this portion is actually equal to 25. All right. Hmm. Now I know our B. I know our B. B is 5. So C is basically equal to 20. C is basically equal to 20. Hmm. Well, similarly, A plus B. So this will be also 25, right? A plus B. Realize. No. 2B plus A is actually 25, right? This is our 2B. This is our 2B. And this is our A. So this is actually 25, right? So as A plus 2B is 25, and I know that B is actually our 5. So A is actually 25 minus 10, that is 15, right? So A equal to 5, sorry, A equal to 15, C is equal to 20, B is equal to 5. So what is our D? D is equal to 40. So this is the thing. This is the thing. Clear? No, I don't need the height. I actually don't need the height. I don't need this height. Okay, I will try to discuss the same problem, and I will try to do it a better solution this same problem in the next class, because this problem I know it getting bit confused. So I will try to discuss the same problem in the next session also. And if some other people take, I will try to say, yeah, I will say to re-explain. But actually the live is actually getting long, and everyone actually getting bored. So I actually say to re-explain, or if I take the session, I will re-explain this thing. Okay, but actually this basic idea will be same, that I have to draw this construction and this thing. Or I am thinking that if I can do with any inequality or not, if I can do with an inequality, it will be better. C will be 20 because B plus C, realize that twice of A plus B, sorry, B plus C is actually equal to 25. Yes, okay, why B plus C is actually equal to 25. So I have to draw the figure bit. Okay, let's draw this thing and try to clarify it in this session, because in the next class maybe some of people may not join. So let's suppose this is the midpoint. I'm just clarifying it. I'm just re-explaining everything. I hope you can understand. Then what I have to do? Uh, Maybe something A B C D. Okay. Then I'm taking a point E here. I am joining this thing, and then I have to take F. F is what basically? I completely forgot the problem. F is the midpoint of BC. This is the point P, right? Now, if you look for the this CE, if you look for that CEB, so if you look for the triangle CEB, okay, if you look for here the triangle CEB here, you just realize it that CEB here, it is what? Angle means actually A plus twice of B is 1/4 of the total parallelogram ABCD, right? So this is actually equal to 24, 25, right? And now, so this A plus twice of B is actually 25, this thing coming from here, and B plus C. B plus C means actually this thing, B and C. So now APB, APB, okay. Next, what I'm doing, I'm taking it's this thing that I'm taking APB plus APB plus DPC, DPC, APB plus DPC. This thing, APB plus DPC, okay. So what is the sum of the APB plus DPC? Okay. So what is the thing? This equal to half of ABCD. So half of 50. Okay. So this is 25. So APB plus DPC, that mean APB means what? APB means C and this is A. So here I can also do this thing that twice of A plus C. So twice of A plus C is equal to 50, right? Now I find out that, okay, so finally I get lot of equation here. So let's make a complete shift and do this thing. So I find out this thing that twice of A plus B is equal to 25 and twice of A plus C is equal to 50. Now I find out B is equal to our 10. B is equal to our 10. So here our twice of A. So here if I put this value, sorry, I find out B is equal to actually our 5. So A equal to 10. If I put the value A here, so C is equal to what happened? C is equal to, I find out it is twice of A plus C, right? Twice of A plus C. Yeah, twice of A plus C is equal to 50. So DPC. Okay, Peter, I will discuss. I'm completely getting confused. Twice of A plus C is equal to 25. Okay, better. I will discuss this particular problem in the next class because I get completely confused with this one. Okay, I will discuss this thing in the next class, or I will say to discuss someone with this problem in the next class. I completely got confused with this one. Extremely sorry, but I'm get completely confused, and everyone getting boring in this particular thing. So I will discuss this thing in the next class. Maybe there is some easy solution, but actually I am getting confused. Okay, so good night. Yeah. Yeah, thanks for joining.